Hi again, Steve here with an exponential decay problem. And specifically, we're looking for the half-life of a given substance that we know decays continuous exponential with a rate of 7.9% per day. So getting into the problem, this is the basic formula that we're going to have for continuous exponential decay. And I have all of the labels right here for all the parameters. So n of t is the remaining substance after a certain time t. N sub 0 is the initial amount of the substance. The lambda here is the decay rate expressed as a decimal. That's going to be very important. So we're going to convert this percent into a decimal. And finally, t is time, and in this case, we're given days. So this actually looks very similar to another formula you may see for continuously compounding interest. I just put that here. Some of the key differences that you're going to see is we typically use lambda as a decay rate. It's used often in a lot of books and in industry, etc. For here, notice that we use R for the interest rate, and it's a positive value. So we want our the money to go up, but in this case, the decay is going down. So very, very quick aside on that. So what I did is I went over to Desmos, and I picked an initial n sub 0 value of 1. You can pick anything you want. It doesn't really change anything here. And I put in this formula here, given at n sub 0, and I directly put in the lambda, the decay rate, instead of 7.9%, express it as a decimal. So that would be 0.079. And then what I did was have it graph, and so you'll see here the color blue. This is the point. So at time 0, the initial value of the substance is 1. So basically, I'm looking at where is it 1/2. And so I've marked that area here, and then I've gone and solved that. So what do we have to do here? We have t over here. So the first thing I'm going to do is divide both sides by n sub 0. And when I do that, what we're going to see is, well, what is n of t? Well, we know it's half, right? So it doesn't matter what n0 is or n of t, that ratio, n of t over n0, is going to be half. So we're going to have 1/2 equals this e to the minus 0.079 t. How do we get rid of an e? We do a natural log. So basically what we're going to see is n of t divided by n0, that's a half, because it's going to be half of the value that we started with. And we're going to take the natural log to get rid of this e, and then we're left with that equals minus 0.079 t. So to isolate t in this case, we just divide by the 0.079, and I just called it x just to give it a line here. So when I go ahead and solve that, you can put that into your calculator, and you should get a value roughly this. And if I look on my graph here, these are 1 units here, or remember t is the x-axis in days. So this would be 5 days, 6 days, 7, 8, just under 9 days is where the value decays to half. Now, again, you could go back and you could have the initial value start at 10 or 100 or 52 or whatever you want. And you're going to get the same value because it's really just this ratio you're looking at, half. Now, what if you wanted to find it decays to a quarter of the time or a third of the time, right? You can start to see the ratio that you would put in here. Okay, so hopefully this is helpful and useful. And if you have other questions, feel free to reach out. Thank you.